Welcome to MRL. In this learning session, we'll be learning the solutions of examples of exercise 7.2, 10 standard coordinate geometry chapter, okay, and that is CBSE syllabus. Now, the first example is given a minus 1, 7 and b 4 minus 3 are two coordinate points and they are joined, AB is joined there, and we have to find the coordinates of CXY which divides the line AB in the ratio 2:3. That means we are given 2 points here, a minus 1 7 and b 4 minus 3, and AB is joined, and CXY is the point which divides the line AB in the ratio 2:3. Now to find out the coordinates of CXY, we have to use the section formula, and the section formula, as we all know, CXY is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. Now let us substitute these values here. M is 2 and x2 is 4, so it will be 2 into 4. N is 3 and x1 is minus 1, so it will be 3 into minus 1, and divided by m plus n, that is 2 plus 3. And same way it is m is 2, y2 is minus 3, so 2 into minus 3, and n is 3 and y1 is 7, so it is 3 into 7 divided by 2 plus 3. So when we simplify, we get 5 by 5, that is 1, 15 by 5, that is 3. So the coordinates of the point CXY are 1 and 3. Okay, 1 and 3, x coordinate is 1 and y coordinate is 3, and that is how we find the coordinates of the point which divides a given line segment in a given ratio. Okay, remember that is what is the application of section formula, which we have already learned. If you have not learned, please go through the basics videos on this particular chapter, that is coordinate geometry, which is already available in on this channel. Okay, now let us go to the next example. Now we are given here two coordinate points again, that is 4a 4 minus 1 and b minus 2 minus 3. Now the coordinates of points of trisection of the line segment, okay, we have to find out. Please understand here, the line segment AB is divided into three parts. CX3Y3 is the point, DX4Y4 is another point which divides the line segment AB exactly into three parts. Now we are supposed to find the coordinates of the point C and the coordinates of the point D. Now it's a very simple example. Again, we have to use the section formula here. Now if I take CX3Y3, then this point CX3Y3 divides the line segment AB in the ratio 1:2. So please understand here m is 1 and n is 2. So using m is equal to 1 and n is equal to 2, and the coordinates of point A and coordinates of point B, we can use the section formula to find the coordinates of point C. So that's what I have done here. CX3Y3 is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. Now m, as I have told you, it is 1 and into minus 2, that is mx2, and n is 2 and into x1 into, that is x1, that is 2 into 4, divided by m plus n, that is 1 plus 2. Same way m is again 1 and y2 is minus 3, and n is 2 and y1 is minus 1, so it will be 1 into minus 3 plus 2 into minus 1 divided by 1 plus 2. So it will be simplification of this, very simple simplification. We get 6 by 3, that is 2, and minus 5 by 3 remains as it is, minus 5 by 3. So the coordinates of the first trisection point, that is the point C here, is 2 minus 5 3. And in the same with the same method, we can go with for finding out the coordinates of point D x4y4 here, but only the difference is here the m will be 2 and n will be 1. So because the ratio of division is 2:1, so taking the values of m and n as 2:1, we can use the same coordinates of A and B to find out the coordinates of the point D. Now I have again used the section formula here, substituting the values, taking m as 2 and n as 1, and substituting the values of x2 and x1, y2 and y1, simplifying, we get 0 upon 3, that is 0, and minus 7 by 3. So the coordinates of the second trisection point is 0 minus 7 3. It's a very simple example, and you should understand the section formula, and that is the application of section formula here. Now coming to the next example. Now we are given again 3 points here, a minus 3 1 0, a minus 3 10, b 6 minus 8, c minus 1 6. Now AB is joined here, AB is joined, okay, AB is joined, and C minus 1 6 is a point on AB which divides the line segment AB in the ratio k is to 1. That means we have to find out here the ratio of division. Whenever we are asked to find the ratio of division, it is always good to use the ratio of division formula. We can use section formula, but there we have to find out we have to solve two equations, and we have to go for finding out the two different values there. But here it becomes very simple and very easy if you take the ratio as k is to 1. So taking k is to 1 as the ratio, using the k is to 1 formula of section, that is section formula, that means C minus 1 6 here is equal to kx2. Kx2 becomes k into 6, and 1 into x1, that is 1 into minus 3, and ky2, k into y2 is minus 8, and 1 into 10. Simplifying, we get k into 6 plus minus 3 k plus 1, and k into minus 8 plus 10 k plus 1. And if you observe here we have x and x. If you compare this value of x and this value of x, we can equate them. So minus 1 is equal to 6x minus 3 divided by k plus 1. Simplifying, we get k by 1 is equal to 2 by 7. So we have got the ratio of division as 2 by 7. The ratio of division is 2 is to 7. So therefore the ratio of division is 2 is to 7 here. So a very simple method. If you take the ratio of division as k is to 1. Had I taken m and m is to n, then I should have gone for finding out the two values of m and n. Here it has become very simple by taking the ratio of division as k is to 1, and try to remember that. Here we are given the 2 points A and B. The coordinates of the points A is 1 minus 5 and B is minus 4 5. Now we have to find the ratio in which x-axis divides the line segment AB, and also find the coordinates of the points of division. Now let us understand what is the meaning of that. Now we are given a point A 1 minus 5 and B minus 4 5, and AB is joined. So it's a line segment AB, and also this line segment AB is cut by the x-axis at a particular point Cx0. Now we have to find out the ratio in which this x-axis divides the line segment AB, and also find the coordinates of the point which divides the line segment in a given in a particular ratio. Now let us understand this. Let the ratio of division, let us assume that the ratio of division is k is to 1, and also the point of division on x-axis is x0, because we know that the coordinate of the x coordinate on x-axis is x, and the coordinate of y is 0 on x-axis. Now Cx0 can be found out applying the section formula, taking the ratio as k is to 1, and the formula is k into 1, that is k into 1 plus 1 into minus 4 divided by k plus 1, and k into minus 5 plus 1 into 5 divided by k plus 1. Now we can equate the x to x and 0 to y. So equating 0 to y here, because 0 is y here, and so also we have the y value. 0 is equal to minus 5k plus 5 divided by k plus 1. Simplifying, we get k is equal to 1. That means the ratio of division is 1 is to 1. The ratio of division is 1 is to 1. Now putting the value of k in x is equal to k into 1 plus 1 into minus 4 upon k plus 1, we get x is equal to k minus 4 k plus 1, and k is 1 minus 4 divided by 1 plus 1, that is minus 3 by 2. So the coordinates of the point C x0, which divides the line segment AB in the ratio 1 is to 1 is 1 is to 1 are x is minus 3 by 2 there. So the coordinates are minus 3 by 2 and 0. Let's go to example number 6. Now in example number 6 we are given 1, 2, 4, 4y, x6 and 3, 5 are the vertices of a parallelogram, and we have to find the two unknowns there, x and y. So now we are given a parallelogram ABCD. The coordinates of ABCD are A12, B45, C x6 and D35. Now ABCD is a parallelogram. AC and BD are diagonals which intersect at O. So AC and BD are diagonals which intersect at O. The diagonals bisect each other. O is the midpoint of AC and O is the midpoint of BD also. Now if we want to find the coordinates of point O, that is the midpoint, then we can apply midpoint formula. So the midpoint, applying the midpoint formula, OX3 Y3, that is the midpoint, we can find out x1 plus x2 divided by 2, y1 plus y2 by 2 is equal to x plus 1, see 1 plus x by 2, and 6 plus 2, that is 2 plus 6 by 2, and therefore we get x plus 1 by 2 or 1 plus x by 2 and 8 by 2 are the coordinates of the point O that is known to us now. Now let us also find out the coordinates of point O of the diagonal BD now. O is the midpoint of BD also. Therefore OX3 Y3 will be equal to 3 plus 4 divided by 2 and 5 plus y divided by 2. Now but the point O being the same, I can equate the RHS of 1 and 2. Equating RHS of 1 and 2, we get 1 plus x by 2 is equal to 3 plus 4, 7 by 2, and 5 plus y by 2 is equal to 8 by 2 here. Now simplifying, 2 will cancel, so 1 plus x is equal to 7, and x is equal to 7 minus 1, x is equal to 6, and 8 by 2 is equal to 5 plus y by 2, 2 will cancel, so 8 is equal to 5 plus y is equal to 8 minus 5, y is equal to 3. Therefore the values of x is 6 and y is equal to 3, and that is how we have found out the values of x and y in this example. Again, an application of the midpoint formula which you have to know. Okay. Now the example number 7, we are given that AB is the diameter of a circle whose center is O2 minus 3. The coordinates of the center are given as 2 minus 3, and also we are given the coordinates of one of the points B1, 4, and we have to find the coordinates of point A. Now if you look at the example clearly, this example is based on again midpoint formula. We know that O is the midpoint of AB. O is the midpoint of AB. That means I can apply midpoint formula. So therefore 2 is equal to, very simple, x1, that is x1 plus 1. So x1 plus 1 divided by 2 is equal to 2, because 2 is the midpoint. Then y1 plus 4 divided by 2 is equal to minus 3, and that's what I have done here. And by simplifying, we get x1 is equal to 3 and y1 is equal to minus 10, and therefore the coordinates of the point A are 3 and minus 10. A very simple example. Please understand and remember the midpoint formula. And you all know that what is the midpoint formula. I have put it as a note here. If A x1 y1 B x2 y2 are any two points, and if AB is joined and CXY is the midpoint of AB, then the coordinates of CXY is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2, and that is the midpoint formula, which is very useful in solving different examples. Now in the 8th example here, we are given the coordinates of point A minus 2 and B 2 minus 4. Now AB is a line segment, P is a point on AB such that AP is equal to 3 by 7 AB, and we have to find the coordinates of point P, and taking the coordinates of point P as xy. Now the important thing is we are not given the ratio of division here. Ratio of division is not given, so we have to find the ratio of division, but we have been given a condition that AP is equal to 3 by 7th of AB. Now using this condition, so AP is equal to 3 by 7th AB, and we have to find M and N here. AP, taking B down, AP by AB is equal to 3 by 7, subtracting AP by AB by 1 and 3 by 7 by 1, and simplifying we get BP by AB is equal to 4 by 7. We have got 1, AP by AB is equal to 3 by 7, and we have got second equation, BP by AB is equal to 4 by 7. Now from 1 and 2, if I divide 1 by 2, I get AP by BP is equal to 3 by 4. AB gets cancelled here, 7 gets cancelled here, 3 by 4. AP by BP is 3 by 4, or AP is to BP is 3 is to 4. Therefore AP is to BP is 3 is to 4. Therefore M is equal to 3 and N is equal to 4. So now we have the coordinates of A, we have got the coordinates of B, we have got the ratio of division, that is 3 and 4. Now just apply the section formula to find the coordinates of P, X, Y, and it becomes so simple there. So substitute the values of M, X2, N, X1, M, Y2, N, Y1 here, and simplify. We get 6 minus 8 by 7 is minus 2 by 7 and minus 20 by 7. Therefore the coordinates of the point P, X, Y are minus 2 by 7 and minus 20 by 7. Remember that. Now coming to the example number 9, we are given two coordinates A minus 2, 2 and B 2, 8. the coordinates of the points which divide the line segment AB into 4 equal parts. That means the coordinates points A minus 2, 2 and B 2, 8 are joined, and we get a line segment here AB, and this line segment AB is divided by 3 coordinate points P, Q, R into 4 equal parts. Please understand that. Now we have to find out the coordinates of point P, coordinates of point Q and coordinates of point R, because P, Q, R are dividing the line segment AB into 4 equal parts. It is a very simple example. Now we can apply the midpoint formula here. Now if you observe, P is the midpoint, Q is the midpoint of AB. So let us find the coordinates of Q first. Q is the midpoint of AB, therefore coordinates of point Q, very simple, x is equal to minus 2 plus 2 divided by 2, minus 2 plus 2 is 0, 0 by 2 is 0. So the coordinate x is 0. Now y can be found out. 2 plus 8 is 10, 10 by 2 is 5. So 5 is the y coordinate of point Q. So we got the coordinates of point Q by applying midpoint formula. Now P is the midpoint of AQ. So I know the coordinates of A, I know the coordinates of Q. I can find the coordinates of P. Very simple again. Minus 2 plus 0 is minus 2 divided by 2 is we get that minus 2 divided by minus 2 plus 0, minus 2 plus 0 is minus 2, and minus 2 divided by 2 is minus 1. So the coordinate of x1 is minus 1. Now y1 can be easily found out again. Y1 will be what? 2 plus 5 is 7, and divided by 2 is 7 by 2. So that is the coordinates of x1, y1 here. So minus 1, 7 by 2. Now to find the coordinates of R, R is the midpoint of Q and B and Q. So therefore x2 can be found out very easily by adding 0 plus 2 divided by 2, and therefore it is 2 divided by 2, that is 1, and y 5 plus y2 will be y 5 plus 8. 5 plus 8 is 13, 13 by 2, and it is 13 by 2. So the coordinates of P are minus 1 by 7 by 2, minus 1 and 7 by 2, and coordinates of Q are 0, 5, and coordinates of R are 1 and 13 by 2. So that is how we can use the midpoint formula to find the coordinates of the points which divide a given line segment AB into 4 equal parts. Now coming to the 10th example, and we are given here the vertices of a rhombus 3, 0, 4, 5, minus 1, 4, minus 2, minus 1 taken in an order. So we are being given a rhombus here, and the vertices of the rhombus are A 3, 0, B 4, 5, C minus 1, 4, and D minus 2, minus 1. Now we have been asked to find the area of a rhombus, Now we all know that the area of the rhombus is equal to half d1 into d2. That means half diagonal 1 into diagonal 2. That means half into AC into BD. So to find the area, I have to find AC and BD. I can find AC and BD by using distance formula. So AC is equal to, the distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square, and then substituting the values of x2, x1, y2, y1 and simplifying, we get 4 root 2 for AC, and for BD again applying distance formula and simplifying it, we get 6 root 2. So I have got the diagonal AC as 4 root 2 and BD as 6 root 2. Now substitute the values of d1, d2 here, that is AC and BD here. So half into 4 root 2 into 6 root 2. Root 2 into root 2 becomes 2. So 2 and 2 will cancel. 6 into 4 is 24. Therefore, the area of the rhombus is 24 square units. So that is what is the application of the section formula and the distance formula in this chapter. The whole chapter is based on two simple formulas. One is the distance formula, the other one is the section formula, and the modified section formula, that is to find the ratio of division, taking k:1 as the ratio of division, and also the modified section formula, which is the midpoint formula, which is used in this. In all, we find that the application, we have learned the application of section formula and distance formula in this chapter. So please learn these examples, understand them, and solve them, practice them, and note down these examples in your book for your future reference. Okay, please learn. Thank you.